Hello guys, and welcome back to my YouTube channel. In our previous video we saw some definition of bubble sort, and then we implement bubble sort using C++. Now in this tutorial we will discuss insertion sort. We will see what is insertion sort and algorithm for insertion sort, and then we will implement it using C++. So insertion sort is a simple sorting algorithm that works similar to the way you sort playing cards in your hand. The array is virtually split into a sorted and unsorted part. Values from the unsorted part are picked and placed in the correct position of sorted part. So now let's see what are the characteristics of insertion sort. This algorithm is one of the simplest algorithm with simple implementation. Basically, insertion sort is efficient for small data values. Insertion sort is adaptive in nature. It is appropriate for data set which are already partially sorted. So now let's take a look at the working of insertion sort algorithm. Let's consider an example of an array having value 12, 11, 13, 5 and 6. Now in the first pass or the first iteration, initially first two elements of the array are compared in insertion sort. Here 12 is greater than 11, hence they are not in the ascending order, and 12 is not at its correct position. Then we will swap 11 with 12. So for now 11 is sorted in sorted subarray. Now in second pass we move to the next two elements and compare them. Here we will compare 12 and 13. Hence 13 is greater than 12, thus both elements seem to be ascending order, hence no swapping will occur. 12 also sorted in the sorted subarray along with 11. Now in the third pass we will compare these two and swap them, and both 5 and 13 are not presented at their correct places, so we will swap them, and then we will compare these 13 and 6 and also swap them. After swapping element 12 and 5 are not sorted, thus we will swap them again. So we will swap 5 and 12. Here again 11 and 5 are not sorted, so we will swap them too. We will swap 11 and 5. This looks similar to the bubble sort, but there is a little bit difference between bubble sort and insertion sort. We will see it in a second. So here it is at its correct position. Now in fourth pass, now the element which are present in the sorted subarray 5, 11 and 12 move to the next two element 13 and 6. Now clearly they are not sorted, thus we perform swap between them. Now 6 is smaller than 12, hence we will swap them, and here is finally our completed sorted array. Now let's take a look at the algorithm of insertion sort. To sort an array of size n in an ascending order, we will iterate from the first index to the nth index over the array. We compare the current element key to its predecessor. If the key element is smaller than the predecessor, then we will compare it to the element before. Move the greater element in one position up to the make space for the swap element. Now we will see the implementation of insertion sort inside our VU Studio code using C++. Here I will type our insertion sort function. It will be a void insertion sort. It will accept two arguments. First one is an array and second one is the size of array. Now I will make three variable I and j for the loops and key for the insertion sort algorithm. Now here we will initialize the key to the ith index of our array. For the first iteration it will be 1 and j to the I minus 1. Now move the elements of array that are greater than key to one position ahead of their current position. So for that we will use our child loop, but this time I will be using a while loop. Condition will be j greater than equal to 0 and jth index of our array is greater than the key. J plus 1 is equal to jth index of our array and j is equal to j minus 1 and then our j plus 1 index for array is equal to the key. So our function for the insertion sort algorithm is ready. Now I will write the function for inting the array void print array. It will accept an array of integer type and size of the array. Less than and I plus plus. So our print function is ready. Now let's move to our main driver code. We'll put the values, let's say 12, 11, 13, 5 and 6. Now the size of our array is size of our array divided by size of our array 0th index. Now I will call our insertion sort function and will pass it the array and our size of array. Then I will simply print this array. So our complete code for the insertion sort algorithm is now ready. So let's try to run this in our terminal. So you can see it has sorted our array using the insertion sort algorithm. Now let's take a look at some time complexity or space complexity of our insertion sort algorithm. The time complexity of our insertion sort algorithm is omega n square, and the space complexity of our insertion sort algorithm is omega 1. So what are the boundary cases of insertion sort algorithm? Insertion sort takes maximum time to sort if the elements are sorted in reverse order, and it takes minimum time order of n when the elements are already sorted. So what are the algorithmic paradigm of insertion sort algorithm? Insertion sort algorithm follows the incremental approach. And next interview question can be, is insertion sort an in-place sorting algorithm? So yes, insertion sort is indeed an in-place sorting algorithm. Next is insertion sort is a stable algorithm. Yes, insertion sort is a stable algorithm. So next, when is the insertion sort algorithm is used? Insertion sort is used when number of element is small, and it can also be useful when input array is almost sorted, only a few elements are misplaced in complete big array. Next, when is the insertion sort algorithm is used? So we have answered this question, and next we have, what is the binary insertion sort? So we can use binary search to reduce the number of comparison in normal insertion sort. Binary insertion sort use binary search to find the proper location to insert the selected item at each iteration. It is normal insertion. Sorting takes omega I at the ith iteration. In the worst case, we can reduce it by omega log I by using a binary search. The algorithm as a whole still has a running worst case running time of omega n square, because the series of swap required for each insertion. Refer this for implementation. Next, how to implement insertion sort for linked list. So how we can implement insertion sort for linked list? So here is the insertion sort algorithm for linked list. First we will create an empty sorted or result list. Then we traverse the given list. Do following for every node. We will insert current node in the sorted way in the sorted or result list. Next we change the head of given linked list to the head of sorted or our result list. So that's all from our today's tutorial. In this video we see what are the insertion sort and what is the algorithm for implementing insertion sort. Then we implement the insertion sort using C++. We make this insertion sort function and then create nested loops and then we run our program and have a successful execution, and our array was sorted in ascending order. Then we see the time complexity and space complexity of our insertion sort algorithm, and at the last we saw some interview question related to insertion sort. So that's all from today's video. Thanks for watching.